In the last video, we learned how to use Ethernet to send and receive messages between a PC and an FPGA board. We used a program called Hercules that uses the TCP protocol over Ethernet to control the LEDs on the FPGA. Now, in this video, we are going to move to the HTTP protocol, which is layer 7 of the OSI model. The HTTP protocol is widely used in web applications. The HTTP protocol uses a TCP connection to establish communication between a web browser and a web server. Here's how a website works. First, we have a web server and a web browser. A web server application can be deployed on a real computer server or an embedded device. For example, an ESP32 or Raspberry Pi can run a simple web server application. Similarly, your Zynq FPGA running Linux can also run a simple web server application. A web browser usually runs on the client, which is a PC or laptop. The connection between the web server and the web browser uses HTTP over TCP. The TCP connection itself can be established with Ethernet. Here's how the web browser communicates with the web server. First, it sends an HTTP request message to the web server when you type a URL in the address bar. This is an example of an HTTP request message from a web browser that will be sent over TCP. Then, the web server will send a response message. This is an example of an HTTP response message from a web server that will also be sent over TCP. Now, let's dive deeper into the HTTP protocol. In the HTTP protocol, the message consists of two main parts, the header and the body. The header and the body are separated by a blank line. In this example, the content of the body is an HTML page that will be displayed by the web browser. The HTTP body can be blank, for example, when the browser sends a request to the web server. In this video, we are going to focus on how to create a simple web application on the Zynq FPGA that displays a hello message in the web browser. To create a web application, you typically build two main parts, the front end and the back end. The front end is what users see and interact with in their web browser. The roles of the front end are sending HTTP requests to the back end, displaying data received from the back end, and managing user input and interface behavior. The front end can be created using several technologies, including HTML, CSS, and JavaScript. Here is an analogy of how HTML, CSS, and JavaScript are related to each other. HTML provides the structure, CSS controls the look and feel, and JavaScript provides the functionality. In this video, we are going to use HTML with Bootstrap, a CSS framework, and jQuery, a JavaScript library. The backend is what runs on the web server, handling the logic, database, and APIs. The roles of the backend include receiving HTTP requests from the front end, processing data and performing business logic, communicating with databases, and sending back HTTP responses. The backend can be created using several languages, for example, Python, JavaScript, PHP, Java, etc. In these languages, there are many frameworks available that make it easier to develop a backend. In this video, we are going to use Python with the Flask framework. Now, let's move on to the practical part. I have logged into the Zynq FPGA running Linux. Let's create the project folder structure for a web application using Flask. First, create a folder called Web Server. Then, inside this, create two folders called Static and Templates. The static folder will be used to store the CSS and JavaScript library files, and the Templates folder will be used to store HTML files. This is a typical way to organize your project into different folders to keep everything neat and structured in the Flask framework. In the Templates folder, create a new file called index.html. Then, add the following HTML code. The HTML code consists of a header and a body. In this code, we are simply displaying the text hello in the web browser. Now, in the parent folder, create a Python file called app.py for the backend. Then add the following Python code. In this code, we define a route for the home page. So, when the web browser sends an HTTP request to the FPGA, it will read the index.html file and send back the response. Now, let's try to run this simple web application. From the web browser, we can go to the FPGA's IP address and port number 5000. So, here is our simple front end displayed in the web browser. Now, let's add a little style to our front end to make it more stylish. First, you need to get the library files for Bootstrap and jQuery from my repository. Then, upload the files to the static folder on your FPGA board. Next, modify the HTML code by adding the following lines to import Bootstrap and jQuery. Finally, we can test Bootstrap. For example, we can add some style to the hello text. Now, let's restart the server and then refresh the web browser. Here is our web page that is styled with Bootstrap. If you're interested in learning more about basic Verilog, RTL circuits, integrating an ARM processor with your RTL module as part of a system on chip, and working on a neural network project, be sure to check out my online course through the link in the description. By enrolling, you'll also be supporting this channel and helping to keep it running. If you enjoyed this video, don't forget to like, comment, and share. See you in the next one.